Well, good afternoon, everybody, and happy Friday.
Happy
Welcome.
Friday, Brian.
Thank you. Happy Friday to you, Natalie, and happy Friday to everybody watching. Welcome to today's Endless Studios live stream for Friday, July 24th, 2020. Uh, I'm Brian, and Natalie is here as she's wont to be. How's
That's right.
everything going, Natalie?
It's pretty good. I'm always glad when it's Friday because I look forward to chilling out on the weekend and playing video games.
But there's no live streaming on the weekends. How could that be more fun than live
I
streaming?
know. I know I'll miss you.
Well, I will probably also be playing video games. I can't deny it. So usual kind of stuff on the live stream applies. If you're part of the course and you're watching, please drop us a line in the chat and say hello. And if you're part of the course and you're not watching, why aren't you? And that would be my question, though you probably aren't hearing me anyway. And if you are not part of the course and you are watching, please say hello too, because that makes us feel good. Um, so I think, and of course, if you have questions about anything in the course, or you have questions about anything in general, or comments on what we're doing, please feel free to ask those in the chat too. Hey, Miss Rogers. Yeah. Okay. And so I think just a little administrative business today, Natalie, and then we're going to get back into the business of our VR shooting gallery implementation. So I think as folks taking the course know, this was intended as a 2-week course pilot. It is now the end of those 2 weeks. Hey, Ronan, it's the end of those 2 weeks. So you are free to continue working through the course in Moodle. We will be monitoring the Discord, in the coming weeks as well. So if you have questions and when you need feedback and all that good stuff, the Discord will be the place for it, and we'll keep up to date on that. We will not be streaming uh, live next week, so there will be no live streams next week, which would be the week of July the 27th. So no live streams the week of July the 27th. But again, we'll be there on the Discord. And if you want to keep going in the course, you are welcome to. If you don't want to keep going in the course because it was 2 weeks for you and that's it, that's absolutely fine too, and we'll still be friends. If you want to stop working on the course right now and maybe come back to it later, it'll probably still be around, so that's probably a safe thing to do too. And all of those options are available to you. The world is your oyster.
Yeah, I see Ronan saying, is it okay if we didn't finish? And of course, the answer to that is yes.
Yes, it is.
Um, everyone does this at their own pace. And the cool thing is that, even though we're not live streaming, you'll still have access to the materials.
Yep. Um, oh, thank you, Miss Rogers. Thank you for participating in it. And again, please keep it, going if you want to. We'll be there to check out what you do. Cool. So I think, Natalie, with that out of the way, we are ready to get back into stuff. So let's take a quick look at our implementation plan and kind of set up what we're working on today. I've got that up on my screen here.
Great. Yeah, let's check it out.
All right. So yesterday we finished our crits and multipliers work. Let's just go ahead and put a strike through that top line as well because it makes me feel like I accomplished something. And we started work on the enemy waves, and in particular the wave manager system, with Natalie leading the implementation. Natalie, as the leader of that implementation, is there anything you would like to mark as checked off on this list?
Sure. So I did declare that variable that tracks maintain current wave state. So I feel like that first sub bullet there can be checked off. Um, and then detect when the conditions that trigger a new wave have been satisfied. Point threshold. So we basically got to that. Um, but I think that we need to talk a little bit about the for loop I wrote before we
That's
can
right.
really fulfill exactly how I addressed that in this script. So it is, in fact, implemented, and we've mostly talked through how that works because we talked about getting a reference to the game manager and pulling in the current score. And what we have yet to talk about is how I'm reacting to the score in the Wave Manager script
Right.
and having that score kind of trigger the transition into a new wave.
Okay,
So
so
let's not cross that yet.
let's not cross that one off, and that's where we're going to pick up today then. Uh,
Yep.
cool. So I think as the driver of that implementation, Natalie, I'm going to bring up your screen now if you're ready, and we'll just get right into it.
Sounds good. If my picture shrinks, you can send us to the no talking heads version once again.
Yes.
But of course, here we are in the project. Um, you know, at the end of the last cast, I teased that we were going to do more. What was it I said, Brian? It had to do with like programming being juicy.
Something to that effect, or tasty maybe, one of those two.
Oh, whatever it is, it's a fruit, and the fruit I'm picking is a watermelon because I had some delicious watermelon today, and so we can kind of just sink into the refreshing sweetness of the for loop and the array, which are the two things we need to learn about to understand my wave manager implementation.
And I suppose if programming is a watermelon, then the uh, seeds would be bugs, right?
Yes. Oh
I
my
think
gosh,
that's
that's
right.
such a cute image. I love that so much. I know. And of course,
I did
you
really
know,
well on the analogy section of the SATs back in the day.
I know. Well, that was very poetic of you too. Yeah, and of course, just like in a seedless watermelon, the idea is that there will be no seeds, but there's always one or two.
There are always one or two, even in the seedless one.
Yep, yep. So we were going to kick off today by talking about these two really important programming constructs as used in C Sharp and game programming in Unity. So the two things that we're talking about today, again, arrays and loops, exist in most programming languages. We talked about that, Brian, when you brought up generating a random number. The idea here being like, this is a thing you can do, and then in C Sharp, this is how you do it. And
Yeah, yeah. I'm sorry. Go ahead, Natalie.
oh yeah, yeah, yeah. So like the thing we're talking about here is there's actually kind of two things you need to learn. You need to learn what are all the things I can do in a programming language. And then separately but connected, you also need to learn how do I actually do that thing in this programming language.
Yeah, and I think that that's something that when it comes to learning programming, most people find learning their very first programming language, uh, somewhat difficult. And then when they learn another programming language, it gets a lot easier because the concepts are essentially common to all programming languages or all programming languages of a certain, let's call it a certain style. And you're really just learning the particular syntax and some of the details of how you do things in a different language and some of the little optimizations and things that some languages are better at than others. You guys have already encountered a lot of concepts that are like that are really the foundational computer science concepts. And maybe it's worth now just reviewing what some of those are because we see a lot of them in your code, right? We have this notion, Natalie's code here is inside this block of code called void update. That's a procedure. Natalie writes the code for this update procedure. Right off the bat, when we get inside that procedure, we see the word if, which means that this structure here, as Natalie talked about yesterday, is a conditional statement. That's something that causes this code to only execute under a certain circumstance, specific circumstance where Natalie wants it to, right? This code makes use of variables. And we talked about those when we did our crits implementation, where a variable is a container that we reference by name in our code that can store particular values. Like that, we used a variable to hold the particular value of our score or of our crit rate. And Natalie is using the score variable again here because she needs to know what the value of the current score is to make decisions about what wave we ought to be in. And we're, as Natalie mentioned, we're going to learn a couple new concepts today, being a loop specifically what's called a for loop, and and arrays, which relate back to variables.
Exactly. Yeah. And the thing I think about when I sit down with a programming language is, how do I write a procedure in this language? How do I do a conditional in this language? How do I do a loop? How do I declare a variable? So just to reiterate, all those things that Brian just said, you would see that in any programming language. And part of your programming education is just to accumulate a library of those concepts so that you understand like what you've got to work with. I mean, in a way, sorry to get on the artistic metaphors again, but it's sort of like, I don't know, like you're acquiring all these different paint colors, right? And without knowing what all the different colors are that you can use, you're not going to be able to paint a really good picture when you
Is
actually sit down.
is the picture of a watermelon?
It is.
Okay, good.
It is. And that has just come full circle in such a beautiful way.
Excellent.
So we need to start out. I wanted to talk about arrays first because I actually wanted to finish the tour I was doing of the inspector settings that I laid out here at the top of the script. Last time we talked about the reference I did here so I could get data from the game manager, but I skipped over these. Oops. I skipped over these next two. And so I wanted to talk about arrays so you guys could understand what those are and how they work. And so I was going to ask you, Brian, what is an array?
This is the Brian mansplains computer science concepts portion of the show. Again, that's excellent. So far, as I mentioned a minute ago, an array is a kind of variable. And so far, up to this point, we've been dealing with variables that just hold a single value. And that's, part of when I said forget about variables that you might know from algebra. Well, bring that back just a little bit of it for a second, right? When you think about an equation where it's like x equals 10, right? Or something like that. That's how we're used to thinking about a variable, right? There's one variable, it's got a name like x, and it equals some particular value, such as 10. And in programming, we do the same thing. Our score, we have a variable for holding the score, and the score holds one particular value for the current score. Perfectly legitimate, perfectly common use of variables in code. Sometimes, instead of just working with one value in your code, you need to work with multiple pieces of value, pieces of data, having to do with the same thing, and the data is of the same type, right? You have to work with, rather than a single piece of data, in other words, a collection of data, a set of data. And an array is a tool for doing that, right? So an array is a kind of variable that, just like regular variables, has one name that you can refer to it by, right? Like x in an algebraic equation. But instead of having just exactly one value, it has a set of values associated with it, all of the same type, right? What would be an example of how you would use that? Well, Natalie's going to have one for you. And the other important thing to know about arrays is when they're actually used at runtime in your game, when your game is running, or when you use them in another type of program when your program is running, your array is always going to have some specific number of items in it, right? And that's an important thing to know about arrays as well. So that's kind of what an array, in the very abstract sense. We'll start with the abstract definition, which is very, very abstract. And I'll warn you, Most people have no trouble getting the concept of a single use variable, right? Like x equals 5 or the score equals 110. Arrays are where this starts to get a little more advanced. It starts to get tricky, but they're very common in programming because they're very useful. And I think how we're going to see Natalie use them today. And Natalie, I haven't seen how you're making use of them yet, so it'll be the first time I'm seeing it. But the way Natalie is using them today, I imagine, is going to demonstrate one of the really useful things, or more of the really useful things about arrays and why they're so common in code.
Yeah. I hope it's useful. So yeah, I actually have a couple in here. And let's take a look at these and we'll just sort of fill in the blanks on how this really abstract concept actually works in an implementation. So um, I'm going to talk about this one first right here. And I decided to declare an array up here of spawners because I knew that there were spawn points in the scene and I wanted to be able to access whatever number of them was in the scene. And even though I could actually just open the scene and um, count how many there are, and I could create a single use variable for each one in order to connect up with that spawner and interact with its data, which I knew I wanted to do. I said, I'm going to make just an array that can be arbitrarily long so that if later I wanted to change the total number of spawn points in the game, I wouldn't have to come in here and create a new variable. I would just change the length of the array.
So let me reflect on that, Natalie, and sort of how that relates back to the abstract description of arrays, right? And the problem you're trying to solve with it, because again, super common problem. Natalie, in writing her code here, wants her code to be flexible, right? She wants it to be able to accommodate however many spawn points a designer wants to put in this game, right? Which is not something, as the person writing the code here, Natalie, necessarily is going to know. She doesn't want it to be limited to a specific number. She wants it to be able to accommodate any number of spawn points that the designer might choose to have in the game. And if Natalie always knew there was going to be one spawn point, or if there were going to be 3 spawn points, and didn't care about the flexibility, Natalie in this code could have 3 separate single use ordinary variables, like a variable for spawn point 1, a variable for spawn point 2, and a variable for spawn point 3. But by using an array here in her code, Natalie is saying, I'm going to be able to keep track of spawn points, and I can keep track in my code as I make use of this variable, is going to be able to work and function no matter how many spawn points there actually are in the game, right? And that's why she's doing that. Doesn't matter if there's 1, 100, 1,000, doesn't matter. My code is still going to work, and my code will be the same no matter how many there actually are, right? And that's the key advantage of using arrays. It allows the coder to write code that can accommodate an infinite number, effectively, of objects that might appear in the game when the coder can't know that in advance. Now, that may sound a little contradictory to something I said about arrays earlier, because I made a big deal out of saying, but an array always has some specific number of things in it. And indeed it does when the game is actually being played at runtime, in practical use. So the game might have 3 spawn points, or it might have 4, or it might have 1,000 from the perspective of this code. But in fact, it's not going to have an infinite number of spawn. It's going to have some specific number of spawn points in it, and whatever that specific number is, that's what it's going to have, right? So you can think of it, this way. Everybody, if you're going to run, you're going to be on a soccer team, right? You need your cleats to wear when you go play soccer, right? Everybody who's going to play soccer needs cleats. Um, and everybody who needs cleats needs some specific size cleats for their shoes, right? You know, we don't care, so we can make a rule that everyone in the soccer team has to wear cleats, right? And that rule cannot specify the size of every player's cleats, right? And that is totally cool. That makes sense. Now, if I went to Natalie and I said, "Hey, Natalie, I'm going to the store to buy cleats for the team. What's your shoe size?" And Natalie said back, "I have no specific shoe size." Right? That wouldn't make any sense. Natalie has some specific shoe size, but from the perspective of the rule book, we don't care what it is. But from the perspective of, well, now it's actually time to go play a game and you need to put your shoes on, Natalie, we care very much what it is because you don't want to be in the wrong size cleats.
Exactly.
And the same is true of arrays. The code doesn't care how many there are, though at runtime there will be some specific number, and what that number is matters very much to the game because there probably couldn't be a thousand spawn points in the game. Would probably be crazy.
Yes, that would probably be too many. But actually, we can get a visual on this because, you know, creating this up here in my inspector members section means I gave the game designer, right now, of course, I'm the engineer trying to create this flexible implementation, but I've made it possible for the designer actually to, in the Unity editor, decide the length of the array. So I'm going to click back into the Unity editor and select my wave manager in the hierarchy so we can check this out. Here it is on the right, here in the inspector. We've got the game manager reference that I talked about in the last cast. Watch it on YouTube if you missed it. And then below that, we've got this section that says spawn points. Now, if you recall from the code, let's pop up Visual Studio once more. This array is actually called spawn points. And Brian, when he initially explained how you create settings that are settable in the inspector, mentioned that Unity will take variable names here in this inspector members section that are, marked with this declarative tag, and it actually formats it nicely so you, as a non-programmer, could understand what that variable is. So it's done that for me there in the Unity editor. And if I unroll this, you can actually see as the designer, I've been wearing both hats in this implementation. I've set the size of the array and been able to create 4 slots where I could pass in a spawn point. Now, I can set this to be any length. I can put it down to 1. I'm not going to type 1,000 here, although I'm aware there's at least one person watching this right now who's like, put 1,000,000 in and see what happens.
Yeah.
Yes, I agree that is a common impulse.
Go big or go home, man.
That's right. That's right. But, if I put 10, it's going to create 10 fields. And what I have here specifically to this implementation is I have an array of spawners. And what that's referring to is the script attached to the game object that's responsible for spawning drones into the scene when I'm playing. So as you saw when we started here, we do actually currently have 4 in. And I'm not sure my references are intact because I just...
you just changed the number, right? Yeah.
Exactly. So I'm going to actually reconnect this with the spawn points that I have in the game, just to remind you guys how this works.
Why don't you go ahead and do that reconnection? And while you do it, Natalie, I'll just do a little commentary here, because we did show this process yesterday, but I want to go over it again. So, we talked about adding variables in the inspector where you could specify a value, when we had our crit implementation, we said, the crit rate is 25%, and you typed in 0.25. Natalie is now picking objects. She set things up in such a way where she can pick objects from the hierarchy of things in the game world that are valid objects to go in this array, spawners, and put them into these 4 slots that she's created because she said her array has 4 elements in it.
Exactly. So that should be working correctly now. And, of course, sometimes this breaks. So I always like to repass the references just to make sure it's
I
working.
think you were smart to do that.
Yep. And, again, what I have now is I have an array that's holding references to all of the spawn points in the game. And now I can interact with the data that those spawn points have. And the reason I wanted to do that is because, let's bring this back. I have it on my screen too. We wanted to uh, change things like rate of enemy spawning, which spawn points are active, and movement speed, which I believe is set by a spawner. And so I want to be able to change those values when the waves change. And to do that, I need to interface with all of the spawners in the game. Now I have the ability to do
Right,
that.
because now you have this array which contains a collection, if you will, of the spawners in the game because you've set that up that way.
Exactly.
Yep. So
That
now because
is,
you have references to them all in one place. Later on in your code, when it comes time to actually write the code to change the enemy settings, you have the ability to do that.
yep, exactly. So let's not spend too much time on it, but I wanted to show the other array I'm using.
Okay.
And this will provide a nice contrast in, uh, the kinds of things you could do here with declaring an array and then letting the game designer use that array in the inspector. So I created a second array called levels. And for this one, what I wanted to do was enable the game designer to decide which point thresholds tip you into the next wave.
Got it. Okay.
So does that make sense, Brian?
Totally makes sense.
Yep. So I did the same thing. Uh, you can see here that my spawn point array, the type for the array is here, followed by these two, what do you call those? Straight brackets,
Square. I
braces.
call them square brackets.
Let's go with let's go with that. It's curly braces and square brackets.
That's
So
and that is what I call them, and I realize that makes no sense. But
as long as we call them the same thing, it's all good. So of course that tells that the computer that is an array. And down here, my type for the array is integer, and again, following by square brackets to indicate it's an array. So back in the Unity editor, um, again, I've got this little header here just to tip me off that I'm dealing with these thresholds that send you into the next wave. What I have set up here is, once again, this is arbitrary. I could, again, make 1,000 levels or waves, or I could make 2, but I made 4 here to start. And what I did here, similarly to with the spawn points, I typed 4 here. That gave me 4 fields. And then since I'm just dealing with integers, whole numbers, I didn't have to drag anything in there. Instead, I needed to think about in the game what would be some logical point thresholds to change the amount of enemies spawning and the movement speed, all of those parameters. In other words, to increase the challenge and difficulty. And I put in some initial values, which may not be the values we end up with because we want to play test this. But I said, okay, after 400 points, I want to go to the next level. And then in that level, I need to accumulate up to 1,000 before I hit the next level. 2,000 is the cap for the one after that. And then 3,600 would be the last time when I increase the difficulty in this trial implementation.
mm-hmm. No, that makes total sense. Those seem as good a values as any. And again, the nice thing about using an array here is, as was the case with the spawn points, this lets a designer have a game with any number of waves in it that they want. We might play this and be like, oh, let's add another wave. Let's add another wave. That's too many. Let's take one away. We can do that with the system now, and the code will still work.
Right. And a more rudimentary application of this would be to what's called hard code these numbers in the script.
Right.
And I will commonly see folks, and it's very logical to do this, writing a lot of conditionals. If points equals 400, and then we do all of those calculations. If points equals 1,000, we do all of these change the data. You can definitely do it that way and create this cascading thing of conditionals. But every time your designer is like, oh, I want to add one, or oh, I want to take it away, or that was too many points, the developer is going to have to open the code and make those changes.
That's such an important issue, and I'm glad you brought it up. It's one of those things that I'm sitting here, I'm going, man, I wish I had planned to talk about that, because it's such an important topic, and you're doing it right, Natalie, I think, because this is a skill as a coder you learn over time, right? Natalie used the phrase, that's a very rudimentary thing to do, to like have all those if statements in your code. And I think that's a very natural reaction for someone who's new to coding, and because conditional statements are pretty straightforward to understand. And so you use the tools you know how to use, when you use the tools that are in your tool belt, right? So it's very understandable. But one skill you learn as a computer scientist as you progress is you learn how to take a very specific solution, like hard coding 4 waves with specific point thresholds in your C# script. And you learn what you can do to make it a little more generic, or a little more flexible, or that it'll work in a wider set of cases. And so Natalie realized that for honestly not very much additional effort, maybe arguably even less effort, it'll certainly make for cleaner code. Natalie can have a very flexible implementation that will still work and support any number of waves and any number of spawn points, versus one where specific ones were hard coded, and every instruction was like a conditional statement in code. That's a way better design. It's a way better system. It'll be more efficient. And I actually think it will result in clearer, easier to read code with less lines of code in it, which is something to strive for too.
Yeah, I really agree with that. I mean, honestly, thinking about this, one of the things that can give you the motivation to learn to write code that has this kind of function is working with other people. And I'm working with you on this project, Brian, and thinking about that, what I would like to do, and even on a 2-person project where we both understand programming, I still want to make it so that if you sat down, pulled my changes down out of the cloud, and saw, oh, a wave manager has been implemented, you might be able to focus on the game design side of it by thinking about what these numbers should be, which is a whole process of deep thought on its own, and not have to open the script at all.
Right. And which is the goal in something like Unity, right? Where you have this nice ability to give designers access to make lots of changes in your games without ever having to touch code. Because maybe you're, and again, as Natalie says, in this case, Natalie and I both understand C#, and we both understand the Unity editor environment. But that's often not the case on teams. On our team that actually the team that builds the Endless Mission, we have a fantastic game designer named Greg. And we have Greg makes jokes at his own expense, because Greg right now, he'll go on at great lengths about how he doesn't code, and how he's again, this guy's a professional game designer who's really good and has worked on many game projects that you would know over his career. And he jokes about being kind of coding phobic, but he can get in and make amazing levels in our games because the game, that's his skill set, and the engineers who made the systems that he uses, like Natalie is doing here, did that in a smart way where it really empowers a designer to make varied and interesting and personal things without having to write a line of code.
Yeah. Greg makes amazing stuff. I would just say, I think if you did get a beta key and you're in the Endless Mission, you can see some of Greg's level designs in the content library.
Yeah, I think his handle is G Miller.
Yep.
Yeah.
G Miller, and he has a little grr. It's a
Yeah.
little green
Icon. Yeah.
dog. So look for Greg's stuff. It's awesome.
It is awesome.
So we should talk about for loops next, I think, because um, I need to explain for loops to you guys so that I can actually also explain another fantastic, useful function of arrays.
Yeah, and it's an interesting relationship. Did you want to explain for loops, Natalie, or did you want me to do Brian mansplain something else?
Well, Brian, you give such good explanations of theoretical programming concepts. I mean,
Well,
tell us
how about we
the high level.
yeah, let's how about how about we tag team this one? Let me I'll sets it up and you knocks it down. Okay?
That sounds
Cool.
perfect.
So, I think to understand a for loop, we have to start with what's a loop, right? So if you've progressed to the point in the course where you've watched some of the videos on coding, you've heard us talk about really all code is a set of instructions, right? And when we've been looking at this program and we did some of the, let's look at the code here in the shooter and see what it does, we've been following the steps of within a procedure and saying, well, you do this, then you do that, then you do the next thing. And that's how code works. It works line by line or instruction by instruction, and it goes from top to bottom, generally within a procedure. And it executes those instructions. It's just like if I gave you a set of things to do, like if I was trying to teach you how to do um, a the electric slide, right, or some dance, I would teach you the steps of the dance, right? I don't know why the electric slide. I just dated and dorkified myself completely that the electric slide was the first dance that came into my head. Um,
Yeah, I mean, like, it would have been funny if you'd said, like, what is the, like, whip and nae nae, though? Like, I feel like that would be, like, out of
Yeah,
context.
I
So it
just
makes,
don't. I mean, it's fun. So here's a story about me. So I come from a long line of teachers in my family. My mother and now my brother actually are my mother's retired now, but they're phys ed teachers, and my mom taught a dance curriculum for many years for in high school, which not I don't know that a lot of high schools do anymore, but they still did it. And it was the high school my mom taught at the high school I went to, and so we got 1 year of where we did square dance. You did square dance in 11th grade, and you did ballroom dancing, partner dancing in 12th grade. Or 11th grade was like line dancing, non-partner dancing, square dancing, line dances. And so one of the dances we did was the electric slide, and that's why
yes,
that popped into
I
my
love
head.
it.
There was actually an original one someone came up with to the song Celebration. You know the song Celebration, Natalie?
I think so.
Yeah, so it's kind of funny whenever like we would go to, years and years later now when I'd go to weddings and things with people I went to high school with, you could tell who all went to our high school because when Celebration came on, everybody got up and did the Celebration dance, and I could still do that. I'm not going to do it right now on the stream. I'm just
Oh,
getting comfortable in
I'm
my chair,
bummed.
but we all can still do the Celebration dance. So, but anyway, but right, the Celebration dance or the electric slide has a series of steps to it, and you learn them and you follow them in order, right?
Yep.
Um, and that's how code generally works. But code can do some things that just following a linear go from the beginning to end set of instructions, well, that go beyond that, right? We've seen one of them already, and we see one right on the screen right now, which is a conditional statement. So a conditional statement says only do the instructions inside this statement under a certain set of circumstances, right? And if that set of circumstances doesn't exist, you don't do these instructions, right? And that's one way you can have the execution of your code branch. Do something under one condition and do something else, or not do that thing when the condition isn't present. Another thing that code can do, and that makes coding extremely powerful, and why you can accomplish a lot in a program, or in a game with only a few lines of code, is code can iterate. And that's a word you may have heard before as well. To iterate means to do something over and over again. And so you can write code, and there are structures in programming languages that let you write code that will iterate, where this block of code will do something over and over again under certain conditions, right? And actually, my dance example is interesting, especially the electric slide or the celebration dance, in fact, are perfect examples of this. Because in those dances, you do a series of steps and there's a beginning and an end to that series of steps. But what happens when you reach the end?
You do it
You
again,
do it
right?
again, and you do it again until the song is over, right? And so the electric slide, Natalie, is actually a for loop if you think about it, right? Because there's a
Yeah.
the electric if you do the electric slide to the song, the electric slide, you do some specific number of the electric slide sequences per song, right? I don't know how many it is, but you go through the sequence, let's say 5 times in the course of the song, right?
Right.
That's exactly how a for loop works, right? A for loop is going to do what's inside the loop a specific number of times that the programmer defines. And after it's gone through that loop that many times, it goes on to the next instruction. And that is sort of the setup, Natalie, and then I'll let you knock that down. Now, well, actually, maybe one other thing on the setup. There are other kinds of loops, right, that you can use that will do, what they all have in common is the set of instructions inside the loop will always be done over and over again, right?
Yep.
Um, the way they differ is how they iterate or under what conditions they iterate, right? The for loop iterates the for loop that Natalie's using here um, iterates a certain number of times, a specific number of times defined by the developer, right? There are other loops that will keep doing something over and over again until a certain condition is met, right?
Yep.
So it's kind of like an iterative conditional statement. Those are called do loops. We may see an example of a do loop, or a while loop is the other. A do loop and a while loop are kind of used. Those terms are used interchangeably. We might see an example of those before this project is over. But that's what a for loop is and what loops are generally. So Natalie, you can kind of go into a little more detail on how the for loop works and how it knows to do things a certain number of times, and then what your loop is doing.
Sure. So, you know, one thing I always want to say about for loops is when I started learning programming, I would look at this and I would just be like, what is all of that? It looks really detailed because it has a fair amount of symbols in it, and it has like tiny little full programming statements in there and so forth. So don't be intimidated. I'm going to break it down. This is the syntax for a for loop. So you have the word for here to start, just like you would in an if conditional. Then you have parentheses with some stuff inside, followed by curly braces. Now, while the loop is running, it's going to do the stuff inside the curly braces until the loop stops. So in that way, it's similar to a conditional where it says, if this is true, then I'm going to do everything in here. For is, I'm going to repeatedly do what's inside here until such time as I'm told to stop. Now, figuring out when to stop is what you're doing in this. So what I do here actually, and this is just the sort of standard syntax for a for loop, I very suddenly create a tiny little variable called I, and I set its initial value to 0. This is like my little counter that's counting how many times I go through the loop. And I'm going to need that because I want to decide to say, I'm going to run through this loop 5 times. I need to be able to count to 5.
Right.
And
You need
so,
to know what time you're on right now. And so when you say int I equals 0, you're saying use I to count for me, to track what time this is that I'm going through the loop, and start counting at 0.
exactly. Now, it is actually also possible to start at 1. But it's generally more standard to start at 0. And also when I'm using arrays, it's going to be better to start at 0. Because when you have an array and you want to take a particular item in that array, those items are numbered starting at 0. So if I have 4 items in an array, I have item 0, item 1, item 2, and item 3, and then the length of the array is 4 things.
Right, and that is often throws people off in their programming, even professional developers. And in fact, that getting stuff screwed up in your code because you forgot to count by 0, that there's actually a name for the error that results in, and that is called an off by 1 error, right? Because if you start at 1 instead of 0, then your results are going to be off by 1. And Natalie, there's an old programmer's joke, as you know, that there are only 3 kinds of errors in programming. There are syntax errors and off by 1 errors.
Oh my gosh. Dude, this is like the level of like how dorky this has gotten to be is just like a million, and I'm living.
That is the dorkiest joke I know.
Oh my gosh. Well, on the note of remaining like passionately dorky and in love with the juicy watermelon of programming.
Oh, and actually, and in that spirit, let me just throw out one other term. Let me do terminology overload. So again, this I variable here is, Natalie used the term for it already, is the counter, right? And that concept that Natalie talked about of when you have each of the items in the array, there's item 0, item 1, item 2, so on and so forth. The 0 or the 1 or the 2 is called the index of that item, right? So the first item in an array, its index is 0, right? The second item, its index is 1 in a 0-based array. And so, and just to make things really confusing, C#, the way we're using it, uses 0-based indices for its arrays. Other programming languages sometimes start with 1. Most use 0, some use 1. It's confusing if you're used to one or the other, and then you get lots of off by 1 errors when you switch between the two.
So I feel like the natural question there is, we were talking about for loops. Why did Natalie and Brian suddenly switch gears and start talking about arrays? And the answer to that question is, we are using a for loop to run through all of the elements in an array. So in this case, I want to use the for loop to run through all of the elements in the spawn points array. So essentially, I'll use my fingers to kind of create a visual for this. I want to run the loop the amount of times that I need to hit every spawn point in the array, and change the settings on that spawn point to increase the challenge and difficulty, according to what we laid out in the design plan, which was like spawn more enemies, spawn them faster, give them a higher movement speed, that stuff. So what I want to be able to do is I run the loop once, change, run the loop again, change, that, and that. And so we're bringing arrays in as I'm talking about for loops, because we're thinking about the idea of, another word for this is iterating, which, Brian, you said that when you were talking about for loops. Mm-hmm. Iterating through all of the elements of an array is what I'm doing with this code. So to do that, I'm using the other array. And this is where it was a little bit of like Natalie does a trick here. So bear with me while I explain what I did. So I started out here, I need to explain the conditional, then we're going to hop to the for loop. So finally, here at the end, you're going to get sort of a full picture of this block of code I have here in update. So what I have here in the conditional is I have the current score. Now, I'm checking to see if that score is greater than or equal to the point threshold for the current wave. So if you remember, I have this current wave variable, which I set at 0 in the start method, which in the case of this script only runs once, right when the game starts. And so I'm going to, when I do this check for the first time, I'm going to check if the score is greater than the point threshold that is at the first index in the array of point thresholds that I set in the inspector. So with 0 in here for current wave, what I'm getting is actually this number. So you see it says element 0 here. So that line of code is essentially saying when the player's score is greater than 400. When that happens, I'm going to iterate through all of the spawn points, and I'm going to modify 2 points of data here. So I didn't actually yet, Brian, implement all of the changes that we talked about in the design document. And that is because in this implementation, I wanted to just do the ones that involved interfacing with the spawn points. We had a couple of things that we wanted to change that were related to other scripts.
Okay.
And in this implementation, I thought, let's focus on, what we can do to increase difficulty and challenge by changing the data I have in a spawn point. And then as we iterated on this script, we would look at ways of getting access to, for example, one of the properties that we wanted to change is actually on the drones. And we'd need to do some funny business to get access to that data.
Got it.
So I think what I did here, max open interval is the longest amount of time a spawn point can wait before it spawns another enemy.
Yeah.
So on every spawn point, when I move up a level, I subtract 2 from that number so that the maximum time it waits before spawning is going down. Which, of course,
then the enemy spawn
that means they're gradually spawning.
Yeah.
Yep, exactly. And then this one, min enemy speed, right? So the spawn point happens to be the entity that sets the movement speed of its spawned drone. And so for that property, every time I go up a level, I increase that by 2.
Okay.
So we have more drones coming through every level, and then we have faster drones coming through every level. And with those 2 basic changes happening every time we hit a new threshold, we would gradually see the challenge increasing over time as you hit those points, and these changes are made. Oh, and then there's one thing I forgot to mention. Which is that at the end of running that logic where I connect with each spawn point and change that data, I increment current wave, which means I add 1 to it, which indicates that now I'm on the next wave.
Right, because once you've made these changes, that signals the start of the next wave.
Exactly.
So you've got to update that, which goes back to the maintaining the current wave state issue that we talked about.
Yes.
Earlier.
Now, I did want to mention something, which as I was looking at this, I realized I might have a bug or an inaccuracy in this code. I wrote it yesterday, and now I'm looking at it today. And I was looking at this and wondering why my count here was the length of the levels array and not the spawn points array. And I believe that this should actually be spawn points.length. But I made an error here because both of those arrays were the same length. So the code works as intended, but this should actually say spawn points.length.
You're right.
Yep. And the reason for that is what I want to do here is I want my counter to count up to 4.
Right. The number of, or whatever the number of spawn points in the game happens to be.
Yes, and that is actually a better way of saying it, because thinking of it as four is what led me to make the mistake I did rather than the abstraction that you mentioned.
Yeah. Yeah, and again, that takes us back to the flexibility of using arrays, because whatever the length of the spawn points array is, i.e., however many items are in that spawn points array, this loop will run that many times, whether it's 4, as is the case here, or whether it's 100 or 1,000 or however many spawn points that there are.
Exactly. Yep.
So
And of course,
go ahead,
oh,
Natalie. I'm
sorry.
sorry.
I was just going to say, and of course, again, the micro level there is I'm counting through up to the length of the array. And what I just want is I want to hit every spawn point I
Yep.
have.
Yep.
Yeah.
So looking at this, Natalie, I think certainly to me the logic looks sound here. And again, I think you did another really smart thing from a development perspective, which is rather than implement every detail of what you're going to update on the spawner, now you implemented just enough so that if you were to go and test this right now, you could have a sense whether the basic system of just of managing going from one wave to the next and the settings being applied works, right? Because if that's working, you know, it's relatively trivial to add another setting that you want to update as part of what gets updated each time that there's a wave, right?
Yep.
And well, it's either trivial or it might actually be tricky. Like you mentioned, there's going to be some trickiness to updating one of those settings. We don't have to tackle that trickiness now, and we shouldn't until we know that the basic system that's going to manage it all is working, which I certainly believe this would, looking at the code here.
Yes. And that's exactly what I was thinking when I wrote this. I said to myself, I need to make sure that my logic is sound. And, even just today, I realized I had a little bit of I don't know if I would call that a logic error, but it's in that category of the script runs, but I actually had something in here that wasn't quite right.
Yeah.
And I really want to make sure that this code is solid and that it works the way I expect. And then I could even comment in here any modifications we want to make to increase difficulty.
And you see those two slashes at the start of the line. What that does in C# is anything that follows it on that line is what Natalie said, it's called a comment. And that's just a little note you can leave to yourself or other developers in your code. It has no impact on the execution of the code.
Exactly. And, I think we should run this and check it out. We can actually test it because I've included debug.log at a couple points in here. Brian, I believe you talked about debug.
I did, yes.
Yeah. So you guys know that this would just print out to the console. And what we would be looking at is at the start of the game, we want to see starting out on wave 0. And then down here, we want to see it say new wave, now on, and then to see those numbers tick up as I
Cool.
play.
Yep, I think that'll be a fun way to end the stream for the week. So let's take a look.
Let's check it out.
So while you're doing that, Natalie, and playing a little bit, I want to, in parallel with that, maybe make a couple of comments, right? So, again, as I said a minute ago, I think the technique Natalie is using here is totally sound and is totally gonna work, and was a great demonstration of these techniques. What I'm going to say, and this is not the point of what I'm about to say, is not that what I would do would be better, because I don't know that it would be better at all. It's to point out specifically, had I done this implementation, I would have done things slightly differently than Natalie did, but I would have achieved ultimately the same result, right? And the reason I bring that up is to say there are often different ways in coding to approach a problem, right? So the solution that Natalie did here is perfectly viable, and the solution I would have done is functionally equivalent, right? Why might we choose one over the other? Some of it might just be personal preference. The difference I would have done is I would have used a different looping structure. It's one we haven't talked about yet. And the reason I would have used it is purely out of habit. It has nothing to do with that it's better or I don't like what Natalie did. It's just purely out of what I'm used to doing and have a tendency to do. And that goes way back in my history of learning computer stuff, because I learned programming in a style of programming where it was way more common to use a different looping structure than this. And so I'm just used to it. But perhaps Natalie's approach or my approach might actually perform a little better. And, you know, that might really matter in a game that was very resource intensive and trying to squeeze every ounce of performance out of the computer running it mattered. We might find that when we use Natalie's technique, we get 120 frames per second. But when we use my technique, we get, 70 frames a second on the same hardware. And then that would be a strong mark in favor of Natalie's technique, right?
Oh my gosh, he's up there.
Oh, he's going to get you. It was
No,
really,
no, I'm not going to die.
that's one of the hard things about doing this not in VR is when you get your mouse at a funny angle.
Oh, I know, it's so much harder. And we don't have cursor management because this is only for testing.
And you died. But look, we are getting that log output.
Yeah, so we can actually check this. I put it here so we could see it while I was playing.
Yep.
And of course we have your debugs for your crit system there, so we can kind of scroll through there. We had starting out on wave 0 happen. I got a little sucked into playing, but I did on this one. I checked, and I did pull the shield up, and it had 400 on it when I saw this in the console, which means I'm pretty sure I got the behavior I expected, and I also was pretty overwhelmed at the end. So I think that I was getting an increase in difficulty. I might need to play it a few more times just to sort of feel out, is the difficulty really increasing? Can I tell visually? But I was feeling like a lot more harried than I normally do in that game by the time I died.
Mm-hmm. So, yeah, I mean, it's interesting how when sometimes you just do that intuitively, you end up coming up with something that kind of works and feels balanced. And that's a great starting point as you just really, if we were going to really optimize the design of the game, we would iterate on that part of the implementation and try to get it really, really nicely tuned and feeling good and challenging. Well, awesome. Now, I think that was a great, when Natalie and I were saying offline the other day, we just kind of picked a random set of things, to do here in the project based on some suggestions and some ideas that we had, and then trying to go a little bit for a more arcadey feel. And as we were looking back over the streams we've done over the last 2 weeks, we're like, man, this actually ended up covering a whole bunch. In fact, most of the key foundational computer science concepts and Unity concepts I would want someone to know. We're not even halfway done with the implementation, and we've already hit a bunch of that stuff. And I think that just kind of happened organically, as they say. And that's pretty cool, Natalie.
Yeah, it's amazing how it played out. Like, what an ideal project for an introductory course to game making.
There you go. Well, that is our time for today and our time for this week. So we want to say thank you to everybody for watching. Have a great weekend. And we will post an update on the live stream schedule when we have one, but we will not be live streaming next week again. All right. Well, thanks, everybody, and we'll see you soon.
See you later.
All right. Bye-bye.